for that. So Professor Dr. Linfa Wang, he's the director of Duke University in Singapore for emerging infectious and diseases. So today we're going to have him here like as a specialist, as the unique specialist. We already heard so many talks from doctors, scientists, nurses, pharmacists, and the financial groups, or even our president. So today I think it's unique. I want to explain why it is unique. We invite him to here. So he's also 2010 elected to be Australia Academy of Technological Sciences and Engineering. For in Chinese, I think it's 院士, right? Mm-hmm. And he's the international leader in research of emerging zoonotic. This is a new word for me. Viruses and the virus host interactions. Zoonotic to me, it sounds like it's a virus, a bacteria, or parasites from non-human and transferred to human. So this will get him a little closer to COVID-19, which is not the closest one. The next one, I think, is more put him in a position much closer. He is he's in the WHO SARS Scientific Research Advisory Committee and played a key role in identification of the bats as the natural host for SARS. Remember 17 years ago for SARS-like viruses. That's, we can see from the publication on Science, that's 17 years ago. And he's now, what he's doing with the COVID-19, now it's more interesting. He's in multiple WHO committees. Specifically, there's one called WHO International Health Regulation Emergency Committee. So think about at the beginning of March 10th, the night before that, March 11th, we had the pandemic declared by WHO. So the night before that, we don't know what's going to happen. Everybody was so panicked when we heard so many deaths and the spread of the viruses so quick in Wuhan. But that night, I could imagine how much pressure he has to discuss the issue with all the committee members, with all the emergency committee members, and to reach the decision. I think it's a very wise and good decision. So if you still think he's not so unique, so perfect person to talk, I would like to tell something about his publication. He has about more than 400 publications. They are in Science, in Nature, and the Lancet. And out of these, I didn't read all of them. I read the title, which already gave me enough in confidence to say he is the expert. Even in 2020, this year, he and his group published 1, 2, 3, well, I don't know how many, about scientific publications about SARS-CoV-2, which is COVID-19, in Nature, Biotechnology, Nature, Lancet, and also if you scroll down the list, I did have the list on my screen, but too bad I can share with you. You can see back in SARS 17 years ago, 1903, right? Also, there was publications about that. He is one of the first one who identified that. So I think he's very unique, very much a specialist compared to all other seminars I've gone. And I have known him for a long time, and I thought I would know him better than anyone else. But no, I was completely wrong. When I read all those publications, all the works he has done, I think the best person who can introduce him is himself. So welcome, Dr. Linfa Wang. Wang Linfa.
Thank you.
Thank you.
Thank you for this very nice introduction, and it's a great pleasure to be able to speak to CBA because I'm actually very well connected with the Bay Area. I'm going to declare that, I might be the first one, biological scientist. I arrived in the San Francisco airport on 2nd of October, 1982. So from Shanghai. So from the Huadong Star, definitely I was the first one went to Bay Area, and the second speaker, Zhu Li, came maybe about a year later, maybe. So anyway, so very nice to meet you guys and to see you. I intentionally to talk about, my area of work, and not touching about vaccine and the therapeutics, although we can discuss it later. I saw that you have another talk coming in November about therapeutics. What I'm going to focus you on really today is the origin of the virus, and also this zoonotic, nature, the animal-human interface, okay? So the title is From Hangzhou to Wuhan, and the Wuhan you know about very well, but Hangzhou, I will explain that to you. So as she says, Suming says, a little bit about myself. I graduated from Shanghai in 1982, went to UC Davis, did my PhD postdoc, then went to Australia, and all by accident, then I got a job in this CSIRO Australian Animal Health Laboratory. So down here in Australia, this remains to be the world's largest biocontainment facility. Even American CDC's lab, of course, I've visited many times, is not as big as this. So we have the largest biocontainment. So biosafety laboratory, if you're not familiar, BSL level, 1, 2, 3, 4. 4 is the highest. So we have the largest BSL4 there. And 2012, 8 years ago, I was headhunted to come to Duke and yes, to head the program in emerging infectious disease program. And so I went from the animal health laboratory to a medical school. And because this is a joint venture with Duke University, so every director of Duke and yes in Singapore has also have to have an appointment in Duke. So then I got a professorship in the Duke Global Health Institute. So as you can see, my career goes from Australia, animal health, to medical human health, and Duke now is global health. So that's kind of reflect my research because I do lots of the international collaboration. So today's talk is just to cover a few points, but in very quick fashion, just to give the audience, although you're all biological scientists, I doubt very few of you, will know about bats, so I will go through the bat-borne viruses. And also really in our profession, to me, COVID-19 is totally predicted. It's not a surprise to us. The only surprise is that it travels so fast, and also especially the Western society was totally not ready for it. That was a surprise. Now, virus origin is very important and the early transmission events. And I think it's important scientifically and try to prevent future transmissions. But unfortunately now it's also important due to political reasons, which is unfortunate. Then I will touch why bats, why we have all this disease coming from bats. What's unique about bats? Then philosophically, I'm going to say that, the source of virus, this is bats, may also be the source of lessons and solutions for our future biomedical research. And I will try to convince you of that. Lastly, really in transition to the second talk by Dr. Li Zhu is to really talk about the importance of serology, And then I'll finish up with the lessons learned and basically summarize the comments I made from this Lancet piece I wrote in February. So for those of you not in the infectious disease area, COVID-19 or SARS might be the really highlights, and then you know about the scale and the impact. But for me, who has been working this area for exactly 25 years, a quarter of a century, so I went to Australia. I was trained in UC Davis as a biochemist and a molecular biologist. So my exposure to infectious disease started when I got this job, 1990 in Australia, the Australian Animal Health Laboratory. And then we had a outbreak big in Australia terms. We had 20 horses involved and 2 people. So it's a new virus, came out nowhere, killed 70% of horses and 50% of humans who got it. Contact, so high mortality. And then I have the chance to do the genomics and name the virus as Hangzhou virus 94. So this really opened a new era of emergent virus of bat origin. And from there, 5 years later, there was a big outbreak, a Nipah virus in Malaysia and Singapore, more than 200 people infected and 40% death. So it's highly lethal. And then everybody knew about SARS. My contribution in Australia, we did not have a single human SARS case. So I'll tell you later the story that I joined the WHO mission and went to China. Then I have the hypothesis. Eventually, I proved my hypothesis that SARS virus comes from bats. And then fast forward to 2012, I was in Singapore already, and in Middle East, Saudi Arabia first, then 26 other countries. we had this Middle East respiratory syndrome virus, MERS. And then, although we have known Ebola virus for 40 years, but 2014, we had the largest Ebola outbreak in West Africa. And then, of course, end of last year, we have COVID-19. So it's important to see that, you know, for those of you not in the field, you think it's a real event. For people working in the field, it's really not that real. Plus, these are high impact viruses. I have also worked on other bat viruses which jump out, you know, make people sick, but not lethal. So these are all lethal viruses, but bats carries other viruses. That's number one point. Number 2 point is that almost all of these viruses need an intermediate host to either adapt, transmitting, or amplify before they can reach human and cause disease. So we have horses, pigs, civets, camels involved. And for COVID-19, this is still a question mark. So as I said, you know, ever since the discovery, so why, you know, coronaviruses? Because the coronavirus before SARS was not considered as a important human pathogen, because we, you know, maybe everybody in today's webinar has been infected by coronavirus at least once in your life, because we have this so-called seasonal coronavirus infect human. They cause mild cold symptom, no severe disease. But we discovered a great diversity of SARS-related coronavirus in bats. And we had a serology evidence in Yunnan in China to say that the spillover events, spillover is a special term, basically animal to human jump. That's happening more frequently than we knew. So this is a family tree that I built, you know, in 2012 when we had the MERS coronavirus. So this all coronavirus, you know, in our virology field, when you discover new virus, you put on the tree, family tree. So we have been focused on this SARS coronavirus and all these bat virus. So we were always worried about this virus may jump again. So I was on the committee for WHO and for many national sort of committees. And the question I always get after, you know, 2003 is, will SARS come back? And my answer was very clear, you know, it's going to be yes. Only thing I don't know is when and where, right? When in terms of, you know, what time. Where, there's two connotations. One is geographically, I don't know where will be the next outbreak. And also scientifically is where on this family tree another coronavirus can jump. So when MERS jumped out to human and killed, you know, quite a few people, I was surprised, because if you look at this family tree, you know, it's quite actually separated. MERS and the SARS we consider as two very distant branches. So if SARS can jump and kill humans, MERS can jump and kill humans, imagine all these viruses in between and surrounding these clusters. So after MERS 2013, you know, I was invited for an interview by a science journalist with Straits Times. You know, this is the #1 newspaper in Singapore. And she pushed me to predict, to say, any chance for another outbreak. And, you know, I'm a very conservative scientist, but in this field, I'm very confident. I say, you know, you can bet your life on it. Almost certain that in the next 10 years, a new killer virus spread by bats will emerge. So that's 2013. As a scientist, you know, if your prediction get, you know, confirmed, you should be happy. But in our profession, unfortunately, when your prediction get right, it means there's an outbreak and a human has to die. So that's kind of very sad that I got it right. And then people said, is that a fluke? You know, I mean, you predicted during that interview. I said, no, you know, I have this grant, you know, collaboration with the Wuhan Institute of Virology in China. The title of this grant is Come Back to the Next SARS or Most Likely Emerging Infectious Disease. So we were prepared by active surveillance to really get ready for this. And just last year, only 4 or 5 months before the COVID-19 pandemic started, I wrote a review in this current opinion in virology. They asked me, you know, among the known unknowns. Known unknown means the virus we know, but specifically which virus will jump, we don't know. So it's the terminology we borrow from Donald Rumsfeld when he was talking about terrorists, right? You have the unknown unknown, known unknown, and the known knowns. So the known unknowns, to me, the most dangerous, as I said, is bat coronavirus. Okay, so that I predicted, you know, just the middle of last year before the pandemic. Okay, so origin, early transmission events of this COVID-19, of course, is still being debated and still being researched scientifically. For me, that the origin are more certain, most likely it's another bat coronavirus. And I will tell you the data, you know, was coming from the Wuhan Institute of Virology in the Nature paper. But as I already shown in the second slide, is that most of the backbone zoonotic virus, they cannot jump to human directly. They need an intermediate host. The hantavirus in Australia, we had horses, and the SARS was a civet. So for COVID-19, we think it's back to animal X and to human. I think you guys still remember in the maybe March, early this year, there was a paper came out to say snake could be the intermediate host. And very immediately, this was discounted by scientists like myself, because I think most likely that it is a mammal. And currently, I think a snake is discounted, but pangolin is still being hypothesized as the potential animal X, which transmit the virus to human. But I personally think you need more evidence. So the strongest evidence came from this Nature paper, so this is from Wuhan Institute of Virology, and I'm the chairman of their scientific advisory board. And I work very closely with the senior scientist, Professor Shizhen Li, and she's in the news all the time nowadays. And the first also, Zhou Peng, was my former postdoc and PhD student. So he did a PhD with me in Australia and postdoc with me in Singapore. So I was in Wuhan when this paper was drafted, so I helped with them with the paper. And basically, again, it's a family tree. We always use family tree to try to establish a relationship. So these are the different coronaviruses, not only bat coronavirus, but we have human coronavirus, pig coronavirus, as you can see, mink coronavirus. But importantly is this, the novel coronavirus they published in this Nature paper, they submit, on January 20th. So it's a very rapid, scientific research. As you can see, these are the human viruses, and only one virus very closely from bat called the bat coronavirus RATG13. That's the virus which is 96% identical to SARS coronavirus 2. So the whole genome sequence is 96% identical. For those of you working in the human medical area, I mean, when you think identical, you're thinking of a 0.1% difference. But for virus, that 96% identical, 4% difference is considered the same species, basically. So that's very significant. And in terms of intermediate host, I said the front runner right now is the pangolin, and there are many papers published, and I'm just highlight this Nature paper from Hong Kong. So again, Yi Guang was deeply involved in the SARS-CoV-1 17 years ago. So again, another family tree. So as you can see, a very similar family tree. Now this in black. So these are the novel coronavirus of human, and the red dot means these are the coronavirus that have been identified so far sequence-wise from pangolin. Pangolin's Chinese name is Chuansanjia. So as you can see that the human coronavirus here, the pangolins are already close, but it's in a different lineage. And the only pity, as I said here, is that I'm a strong believer of serology. When you do this kind of surveillance, that you really need to look at the antibody response, because the virus does not stay long in the human or pangolin bodies, but the antibody stays long. So it's much more sensitive if you do the antibody surveillance. And I will come back later in my talk to illustrate that. The point I try to make is that these pangolin viruses are related, but it's no way as close as that bat virus. So the pangolin virus is 90% sequence identity to the human virus, with the bat virus is 96%. So the research is still going on, and I think we need to really dig much deeper. Then I'll come. So the Wuhan seafood, the Huanan seafood market was on the news a lot, right? Because of the wildlife is traded in that market. So for those of you who could not read the Chinese, apologize, but it's very importantly is that in the market they sold almost everything but except pangolin. There is a reason for it, because pangolin is a protected animal species, so it's illegal. We knew that the trading and smuggling happens very, very frequently, but you will not see this, because even if it's sold, it will be sold sort of under the table. So that's, but civet, guozili is sold, both live guozili and also the meat, guozili meat. Now, I think Sumi mentioned my contribution to really nail down bats as the origin of this coronavirus, SARS coronavirus in 17 years ago. So, Yi Guang in Hong Kong U, in May 2003. So this is in the peak of the SARS outbreak, published this science paper. So the SARS investigation is different from the COVID-19. The SARS investigation, the group nailed down the intermediate animal first. They went to a market in Guangzhou and Shenzhen. They discovered that civets carries a virus that 99.9% identical to human SARS coronavirus. But so this is the intermediate and the transmitting host. This science paper established that. But at that time, we still did not know what's the really origin, the natural host. So I was fortunate enough to be selected as one of the 8 international experts to join a special mission to go to China. That was August 2003. And then I formulated a hypothesis that bats can be the natural reservoir. So another few years later, 18 months later, but the paper came out in 2005, so in Science as well. So I was the leading senior author. So this is a joint mission, really, 5 institutes from 3 nations. What we discover is that on sequencing, whole genome sequencing, we have 3 genomes that we call SARS-related or like coronaviruses that has 88 to 92% identity, and we have serology evidence that bats carries lots of such coronavirus. But we failed to isolate live virus. Now that's important because same with the Nature paper that the Wuhan Institute already published early in Nature, it's also based on sequence, no virus isolation. Live virus is actually very, very hard to isolate from bats. So this is a first paper, but it took us almost 10 years, led by Shi Zhenli's group. We went to the cave in Yunnan province and keep sampling. Eventually, we found the virus that now is 95 to 96% identical. And also, now we can isolate live virus because the virus can use the ACE2 receptor, same as the COVID-19 and SARS, okay? So I just try to emphasize that, to get the origin of live virus is going to be a long-term scientific research and need international collaboration. So the current, environment, unfortunately, is not very conducive, too much politics and not enough collaboration. So now I'm going to really try to get you interested about why bats, why bats are such a good reservoir, why we're seeing all these emergent zoonotic viruses jump out of bats and how highly lethal to human, and yet they have been co-evolved with